chapter now. Let's go ahead and look at chapter. Let me tell you guys about this book. Um, did you say you guys use this for residential? These electrical wiring residential, electrical wiring commercial, and electrical wiring industrial are one of the best series that, in my humble opinion, I've ever seen written about wiring. And when we talk about wiring, guys, you're not electricians, but you are expected to know a few things. You're going to be walking into a project and at least identifying a couple of wiring. You don't want to know you need to know the difference between rigid and EMT and the major things. You're not licensed, bonded, or insured to do electrical wiring. You're designers. But other than the mechanical actual work, you should be able to know everything else. So. Okay, so this is just the first beginning class that we do, guys. We will be covering these are 30-some chapters in this book. We don't cover all of them. We used to, but we don't cover them anymore. What we're going to be covering is, I think it's probably 18 of them. So we have 33 chapters, so I picked 18 very important chapters for you guys. Solar photovoltaic system is one of them for dwelling. And we will go over them in the residential part of the project. In the commercial part, I go through the commercial code. It's all code driven. Everything they're going to see is directly from the code, summarized with pictures and nice stuff. So feel free to interrupt me at any time. So I get excited sometimes, so I start going on the different speeds. You're going to see my smart board here running around loose like it goes through. So, so general information and electrical installation. You guys are in the electrical industry, so whatever relates to the electricians relates to you, especially the safety and what's not. And I'll tell you a couple of stories. So basic safety rules. The single most important thing, and I know you guys are not electrician, you're not carrying tools, but you will be in a situation where an open switch gear, energized, panel is open, and you're standing right in there. You have to know two things. You have to know the rules, the safety rules for electrical, and you have to adhere to them, even though you're not carrying the tools. So that's a few things that this chapter talks about guys. Working on electrical equipment, of course. We are in electrical systems. You guys, we live in an information age. Ring circuit, they use it in England. What is a ring circuit? You go online, type ring circuit, to get you all the information about it. So I can't emphasize, guys, you are professionals when you go work for Hunt or Egan or Parsons. You have your laptop, you have internet, things that you don't know. For example, doing estimating for cable tray. You have no idea how to cable tray. Research it. Do research. Internet is so powerful, guys, so powerful. So that's going to be a lot of resources for you to use it for safety as well as for technical information, safety and technical. So that's a few things you're going to go, and we'll highlight a few sites for you. Did I tell you guys I do have two speeds, fast and faster? So you guys gonna slow me down when I get too excited. Am I clear about that one? So if I got too excited, slow me down. There are documents, technical documents you must know as electrical professionals, guys. These are, again, electrical codes as well as safety codes. These are both of them related to electrical. This one, you guys are very, very familiar with this one. NFPA 70, that's the NEC that you guys have right in front of you, that big Bible. If you don't know that code, it's like living in the state of Minnesota, and they say the twins, and you say, who are the twins? That's exactly, if you're in electrical field and you know what NEC code book is like, living in Minnesota and you don't know where the twins or the Vikings are, or the Twin Cities are, or St. Paul. So this is a very, very important document, guys. You're going to make a lot of money if you stay in this field from this document. It really is. We'll talk about it in details as we move on. There's a document, a little document 70A. Believe it or not, for people who do residential, they take the sections related to the residential and they put them in a standalone document, NFPA, and they call it 70A. This is a code for the residential. Not as common. It's exactly the same thing that's in the NEC code book, but just the residential portion of it. 70B, guys, is maintenance code, the maintenance code. So how do you maintain an existing building? So when you become a project manager after 10, 15 years and you get into a building and your job is to maintain the electrical equipment in that building, and you need to have an electrical maintenance plan, That 70p is very, very powerful. Detailed information how to maintain a switch gear, switchboard, a panel, UPS, in details, checklist based on the manufacturer information. 70E is the safety code, directly to the safety code. That's safety in working on the electrical equipment, 70E. 73, so you can see a lot of them. 73 is remodeling. I believe it's a code related to remodeling dwelling. By the way, anybody knows how many documents NFP and National Fire Protection Association have? Guess thousands of them. So if you're confused, you're welcome to the club. When you get their catalog like this, they have literally thousands of documents, which becomes code, which becomes adopted and by states, local government and state governments, and feds, and it becomes the law. A lot of them. So some of them are not related to us, like pipe fitters, and well, they have their own. Others are. Okay, so that's for remodeling. OSHA, of course. OSHA enforces the safety rules in the construction industry. You don't adhere to OSHA, you basically violated the law. So what OSHA does is take all these safety codes, put them in the law, get adopted by our state in the state of Minnesota, and you violate it, you violate the law. So that's how all these codes become a law. NFPA 70E, guys, or 70, this one got adopted by the Department of Labor and Industry through the legislatures. They submitted, it got adopted in July 1st, and when it's adopted by our legislature, it becomes a law. This is now the law in the state of Minnesota, believe it or not, 2014. So that's how these documents become law. It's not just book, it's the law. A couple of other documents, this one, American with Disability Act, they have a lot of information for you designers, guys, very important. How high you can put a receptacle or a switch, and it still meet the American with Disability Act. People with wheelchairs, they need to be able, so there's rules and regulations when you lay out your receptacles and switches in public areas, so it can meet the American with Disability Act. If you work for electrical designers, that you're gonna have a document that's in addition to any secret book, you can't put them higher than a certain, too high so a guy with a wheelchair cannot reach it, or right in the front of a desk where a guy with a wheelchair cannot reach out. And so there's a few rules in the height and all that stuff. This one is National Recognized Testing Laboratory. Those guys, they take a switch gear and they say, okay, this is 4,000 amp. They put 4,000 amp and they blow it up. And they say, yep, it can handle 4,000 amp for 5 seconds. So those are UL, you guys are familiar with them. The UL, they can put a label on everything else. So if you got the UL label, means they have blown up a couple of them to get you the product that you're looking for. So very, very important concept. ICC, International Correlating Committee or something like this. These are equivalent to our NEMAs and what's not, another organization, international organization. So these are a few documents, guys. Hey, a few documents that we have to be aware of. Comments, questions. So if you want, when you become an expert, if you want to add to your library. Oh, by the way, have I told you that all these documents are free of charge, especially the NFPA on the NFPA website? If you go to the NFPA website, they have a free access, PDF access. Very awkward, can't research it, but you can look at any of these documents, including NEC, free of charge. And the reason why they made it free of charge, because people were complaining like yourself. They're saying, if you want this document to be a law, well, I have to have access. This is America. You make it the law. We pay for the law, right? We pay for legislators. So we want to make it accessible to the world Americans. So it is accessible. All of them online. Go to NFPA and you can access them. So that's a few documents, guys. Licensing and permitting. We'll talk a little bit about licensing and permitting. You guys will be doing a lot of plans and specifications with our friend Chad, including symbols and notations. We'll talk about a little bit about these. Electrical inspection and the National Association of Electrical Inspectors. All these guys. Let me tell you a little bit about this book. If you haven't read this book, read it once in your lifetime. And I know there's tons and tons of information, guys, but this is basically like electrical inspectors, International Association of Electrical Inspectors. They put a great documents about updating the NEC book changes and all this good stuff. A great association to belong to. So these are a few things, my friends, that we'll go over. System of measurement, we keep talking about the metric system in the US. We haven't moved fully to the metric system, but you'll be surprised working at Mishad Cooley. You might be working for a company that's putting a data center in the Middle East, or they're putting it in South America, and they're using a metric system. I was working for LRB Beckett, and we had a project in South America, and we were doing it in metric system. So you'll be, especially if you're doing engineering work, you'll be surprised. And some system will be using some location will be using the metric system. So-called nationally recognized testing laboratories. This is the fancy name, or one of them is UL. Those are the guys who test and blow up the equipment so they can get them to be listed. You say this can handle a 4,000 amp. Yep, they blew up. Now it can handle 4,000 amp for how long? 5 seconds? Yep, 5 seconds. So these are a few things, guys, that we will talk about in this chapter. Comments, questions? Comments? Like I said, read it, guys. Please read it one time. A lot of information, especially for you. I always say you're going to spend the rest of your life in this career. Like it. If you like it, it'll make it easier. Okay, safety, safety, safety. You're going to understand, guys. I always I teach electrical safety 70, and I say, as an electrical construction, you guys in the field, you're exposed to two hazards, and you're very familiar with them, of course. Hazard number one is somebody walking with a 2x4 right around you and hit you in the head, right? Or a block, concrete block, fall from the top, right on the top of your head on a construction site. Could that happen? A beam fall and hit you on your shoulder. These are construction hazards. Everybody's exposed to it. In addition to this, you being electrical professional, you're also exposed to the electrical hazard. The dangerous hazard that comes in out of electrical. They will be asking you as an electrical designer and engineers, guys, to go to this switchgear and look at this switchgear. Can we modify by adding another circuit to this switchgear? So I've been in situations as an engineer where the electrician opened the switchgear live, and I'm looking right there, take some pictures so I can send it to the manufacturer and say, can you guys modify this switchgear so we can add another service to it? That's where you can be exposed to live parts, so be very, very careful. Two hazards, the electrical as well as the normal hazards. So safety first. So you can be shocked, obviously. You can fall because of the effect of the shock. And we can have what's so-called arc flash, where you can't, you can be, switchgear is open, and you're standing right in there, not touching anything, and accidentally the electrician who was opening the panel for you so you can look inside and take pictures, that's how we guys get involved. You'll be taking pictures to take it to the field, to the office, so you can redesign the system. So you're taking pictures there, and the electrician accidentally dropped the screwdriver or something inside the switchgear. You have an arc flash. Arc flash, basically, it's a big ball of fire, say 3-foot diameter, and basically engulfing you with a lot of melted copper and aluminum right into your chest. So that's basically the hazard. So be very, very aware. So you get closer into the arc flash area, you put your PPE. So we always start with safety, guys. Rule number one for safety is so-called lockout, tagout procedures. Basically, OSHA require cannot work on electrical equipment energized, period. If you want to change this ballast, the first thing you need to do, turn it off, lock the circuit breaker that feeds it, tag it, and go change that ballast. Typically, ballast and circuits are not as much as, but mechanical equipment and all this stuff require lockout, tagout procedure. Any piece of equipment you work on it, you go turn it off. Not only turn it off, you lock it, you put a tag on it, so nobody else can, other than you, basically open the circuit, and you can go work on it, de-energize. That's the rule. The exception is, if you cannot lock it and tag it, because if you shut it down, there is a bunch of open-hearted people. Their chest is open, they're working on them in a hospital. Can you shut down the system to work there? So these are the only exceptions, guys, that you can work energized. If you introduce more hazard by shutting it down, like hospitals, or if you cannot troubleshoot the system without the system being energized. You get into an air handling unit, you need to troubleshoot it. You can't troubleshoot it without it energized, so you have to energize it and work on it energized. So other than that, you lock it, you tag it, and it is the law. This is adopted by, so you get, if you don't lock, you don't tag, you're liable, your supervisor is liable, you guys are going to be in the field. When you're in the field, you're the supervisor, the project manager, you are liable. If the people who working, your electrician working for you, they don't do lockout, tagout procedures, and you're a manager, you are liable, as well as they are. So it's a law. Somebody got hurt, got killed, you could be sued, you lose your truck and your house, basically. So it's a big deal. And the other thing is housekeeping. How many of you guys trip on a, when you're working in a place, they always tell you as you're not working, but your electricians are. You work for Hunt. You're going in the field. Those are your Hunt electricians. So you have to keep an eye on the people and make sure they don't trip on things. Yes, sir.
Add more on that too. MSHA training, you heard of that?
Um,
Same as OSHA, except it's MSHA for mine.
okay.
You can't even walk through mud. It tracks up areas and then it makes it slippery.
Yeah, housekeeping and
It's
yeah,
like a huge
yeah,
fine.
yeah, yeah. OSHA guys is a big deal. I mean, and they save lives. They really do. They save lives. We take a lot of. I mean, there are rules and regulations for OSHA using ladders and what's not. But housekeeping, as your electrician walking around, you have things laying around. I'm working on this panel, and housekeeping is maybe while I'm working, move this around. Okay? Get the wires and everything else. Keep everything clean as you work on the equipment. Why? Because it creates more hazard. Okay, so you can, for this circuit breaker, so if I want to change the ballast on that one, these ballast guys by required by law right now to have a disconnect on them, so it's easier. So you get in there, these ones, the new ones, you disconnect them, you change them. So, but say if they don't have a disconnect, you want to work on them, they can add a lock right into this circuit breaker. You go turn the circuit breaker off, put your lock on it, go change the ballast. That's the rule. That's the rule. So you can add to an existing panel some locks. Um, the NEC as well as OSHA guys have a term called qualified person. You're going to hear this one by OSHA and NEC, qualified person. The qualified person defined as, like yourself, you have to have the skills and the knowledge in order to be qualified. Can you be qualified without skills and knowledge? No. But that's just one thing. And safety training. So you have skills, knowledge, and safety training. So that's how you become qualified. You have to have the skills and knowledge, operation and construction of the equipment, and you have to have received training on the safety. That's how you become qualified. Now, if you guys have not taken any training on 70E and recognizing and avoiding energized equipment and arc flash, you're not qualified based on OSHA and NDC. So what's in it for you guys when you become a project manager? These are the words they're going to see. Are you qualified when you see people working for you and not working on energized equipment? Any comments about qualified person in the NDC code book, as well as in the
Especially if you're a contractor and you get fined, well, they find the company who owns the ground. And then they're going to look at the company, okay, this company caused us $20,000 in fines, they're not coming back.
Absolutely, absolutely. You'll be kicked out of major projects. Yeah, because the sub is liable, and the people who hire the sub are liable too. So if you're a sub that they hire a general contractor to do work, and you keep bringing a lot of OSHA violation, and you'll be next project you'll be out of the project. So it's a major things, guys. Business continuity, job security, directly related to safety. You don't want a lot of violations. In order to do the electrical work safety, there's something called PPE. PPE. This is called personal protective equipment. Typically, when you're working on energized equipment, you need rubber gloves, insulation shoes or boots, face shields, and safety glasses. That's the idea. And hard hats. You can work in an area without hard hats. These are what you need to work on in a construction site, especially the insulation shoes and rubber gloves to work on, and they're different levels, guys, to work on energized equipment. So that's, again, this is, a lot of these are OSHA and 70. Employers, we just talked about employers. Employers have to provide training. That's why 70E, Hunt and Egan and all those people who work in the field guys provide large 70E training, provide training for their personal protective equipment here, how to recognize it. where there's 4 hours right now we do for 3M, I do them, and a bunch of others. We go there and we train them 70 on 70E for 4 hours. So we have equipment, they dress up, they use them, and we go through the arc flash analysis and how to recognize energized circuits, and we have some exercises that they have to do. And they do it, they do it, I believe, every 3 years. Every 3 years, or whenever there is a new equipment have been added. So for all the people who are working on energized equipment, it's the law. So, and if you like your jewelry and all this good stuff, the last thing you want to do, guys, when you work on energized equipment, or you see your electricians work on energized equipment, is to have all these chains right around them. What is a chain attached to your wrist? Perfect conductive. This is a perfect way of connecting you to the electrical circuit and making you a bulb, basically. So you cannot wear all these jewelries while you're doing electrical work on electrical equipment. Arc flash. Arc flash, like I said, guys, somebody drop a screwdriver, bolt something inside the panel, you arc, you have a short circuit or a ground fault between phasing and the ground. Big ball of fire comes out of it, melt the cover, and the cover starts flying towards you as bullets. You have arc flash, arc blast, they call it. So you have a big wave pushing you, wave sound, and so you have a huge amount of sound. You have a big wave pushing you. If you're on the ladder now, you broke your neck. And of course, you have big fire engulfing you. Talk about ugly situation. And if that's not enough for you, it's so bright that it blinds you too. You can't see. So it can't be worse than that with arc flash. That's why, guys, when you open a panel, work on energized equipment, especially panels, you put your PPE. So put PPE means if you have an arc flash, arc blast, you will survive the incident. That doesn't mean you're not going to spend a couple of months in the hospital if it's a big one, but you'll survive, or your chance of surviving is higher. Arc, this is just a few facts, guys. 35,000 Fahrenheit is the temperature of your arc flash. Imagine that's against your skin. That's where the PPE, they put the PPE. These are fire-rated material that they use, and it can handle high temperature without burning through your skin. And a couple of things. I know you guys are not electricians, but a lot of do not. You can't believe how many. I'm a journeyman and a master, like I said, in Minnesota. I'm a master too. So I've done a lot of stupid things. I always say I get scared when opening panels, especially 480, 277. Don't mess with these without your PPE. 24120, a little ball of fire comes that big, not a big deal, but still, for safety, it's a big deal, guys. Anything is a big deal, especially when you're working on a construction site. You don't want to be fined, you don't want to kill people, you want everybody to work, make money, and go back home safe. So a couple of assumptions: disconnect fluid side of the main, disconnect the main breaker will trip. So there's a lot of assumption, guys. For example, a good assumption that people walk in: the green conductor is always grounded. It's not hot. You never know who wired it, right? I treat every conductor as an energized conductor until you prove otherwise. Is that the opposite of people are innocent until proved guilty? In the electrical, conductors are guilty until they prove innocent. In terms of electrical wire, they're guilty until they're proven innocent. Assuming the circuit breaker is going to protect you. You know when was the last time this circuit breaker tested? Probably 50 years, well, maybe 25 years. You think it's working properly? Well, I don't know. It could be not. Would you bet your life on it? I wouldn't. So these are the things so what does that mean? Shut it down, lock it, tag it, measure the voltage, verify the absence of voltage, which while you're putting your PPE, and then after that you start touching the equipment. So there is a procedure that we use, guys, for safety, and all these for you is a big deal. Electrical injuries, you could be shocked. You get shocked. How many of you guys have got shocked? Oh wow, I counted at least 20 times over my career that I got shocked with 220. A lot of them overseas. And you just get the other, if you're lucky enough, you just shake a little bit and let go. If you're not lucky, I always say, don't grab on things, man. If you touch it, you shock and you let go. But if you grab on things and your muscles cram, you can't let go, that's when you become basically a bulb and you get cooked. the shock. Electrocution, that's when the shock cannot let go of the shock. The current keeps going right through you, through your impedance, and turning you into heat. They just heat you. They cook you like a hot dog, unfortunately. And if it continues, obviously, or if it goes through your heart, it stops your heart. If it goes your blood, it affects your organs. Or if it doesn't go through the major organs, it will just burn your hands and legs and what's not. That's also ESA can create a burn, so be aware of that one. And this is the hidden hazard, guys. Fall. You're standing on a ladder and you get shocks and you start shaking. What happened to you? You fall. Now you didn't get electrocuted, but you broke your neck. So I always tell the people, it's just you're standing on a ladder and you got shocks. What do? You start shaking and fall off the ladder, broke your neck. So all these are major cause, guys, of arc flash, arc blast, or electrocution. Comments, questions. What's in it for you? What should you know? You're designers. You're going to be in the field. You guys work at the airport all the time, right? You guys go there, take pictures, and convey equipments right in front of energized electric equipment. That could happen to you. So especially when they open while they are commissioning and they're opening things, or if you want to modify a switch gear, they open the panel. So, or your electricians are working on it and you are the project manager. Okay, arc flash, steps to take in the event of electrocution. I don't know if you guys remember, the first thing was to grab your call 911, right? That's ask for help, right? Do you touch the people? Don't touch them. We learned this one a long time ago, because you become part of the circuit, you get electrocuted, right? And shut off the power. So that's why most of the electrical equipment is part of the debriefing. Part of the safety training that we do is we debrief. Before you and I'm a master, you guys are working for two unlicensed for one licensed individual. Before we start working on electrical equipment here, we debrief. Okay, where are all the disconnects in the area? So we identify the disconnects for the power system of the area they're working on. So if something happened, you don't sit there and say, where the heck is the disconnect for that panel, right? You already debriefed. You already know where the disconnects are located. That's how you're supposed to work. Then if something happened, you run immediately to the disconnect. You know which disconnect and you shut it down. Now, when I was growing up, we always told that make sure you have a 2x4 next to you too. If all hell breaks loose, you can't find a disconnect. Make sure you have any non-metallic object, and you push them slightly. Don't hit them right here and kill them. Just push them slightly away from the from the circuit with a chair, a non-metallic chair, or anything that's non-metallic. If you couldn't find where the source of the power is, right? Somebody's sitting there and shaking, and where the heck is that? By the time you find the source, he's dead. You have a chair, the non-metallic chair. Just make sure they push him away from the circuit. That's what we're doing. CPR, of course, perform CPR if you know how. And timing is everything. If you let them sit there, they will be cooked. The longer, the more chances that people are not going to make it. Why do you guys need to know that one? Because you are the project managers. You are going to be there in the field and doing all this stuff with the electricians. Proper tools is vital, guys, when you're working with energized equipment. Very important. When the OSHA require you, when you work on energized equipment, they have fully insulated tools. I'm sure if you guys went through the electrical program, you can't use non-insulated tools on energized equipment. Fully insulated, more expensive. They look alike, but they are fully insulated to insulate the voltage up to 600 volts. So, or 15K if you're working 15K. So these are your tools: screwdrivers, pliers, cutters, whatever, strippers. And we have digital meters. When it comes to the digital meters, guys, not all digital meters are created equal. There are stories of people using a digital meter explode right in front of them, in their eyes, and burn them. When you're using digital meter, you want to have, I have one, is at least category 4. You don't buy anything that's not category 4. The ones that they sell for $15, and that digital meter that you guys use in our labs, Ray, you can use them on 120 circuits. You open a panel like this, you need category 4. What's a category 4? It can handle higher fault current, number one, and also transient. There are stories, guys, of people opening a panel, measuring the voltage, just measuring the voltage, and there was a lightning. The lightning hit the transmission line. A transient jumped into the transmission line. Big explosion happened through their meter. They panic, of course, when you say your meter is smoking. They panic, They let go, it escalated no arc inside the panel. Now you're an arc flash. Big ball of fire killed a fireman at that time and the electrician who were working on it. There's stories about these, stories about meters that's not rated to be worked. So always, when you look at your meter, if you have a digital meter, always look for this. This guy is the best. Category 4. Category 4 means you can use it in a 120 circuit, in a 480 circuit, inside a panel, on the line side, or the load side of a disconnect. So if you have a panel like this, and here's your panel, here's your 4,000 amp, and here's your 20 amp circuit coming out of these. If you have one of these meters, and out of this one you have a panel, circuit breaker like a receptacle like this. This meter can be used here, can be used here, can be used here, can be used here, or can be used here. This guy, the only place that this guy can be used is right here. Category 1. And then 1, 2, 3, 4. And there's 2 can be used in this side, and 3 can be used up to here. 4 covers everything. Always look at category 4 when you use your meters. Digital multimeter. Fluke, these big Fluke ones, they are category 4. Training. There's a lot of seminars, guys, and training that you can do when you become a professional. Obviously, OSHA provides a lot of training about safety. Here's a couple of organizations you should be aware of. Not now, you guys are stuck with your friend Chad of testing you, and we're going to talk about CAD and Revit. When you become in the field and you don't have Chad to harass you, pay a lot of attention to the training that these organizations do, especially if you want to grow in your career. You become a project manager, you have to go to OSHA training. Even as a designer, because you're working with electricians, you're running crews, you're the project manager in the field. Those guys that work for you is your responsibility. So NFP, especially NFP and OSHA, has a lot of stuff, guys, that they can provide in terms of training. Okay, moving on into so a few things about, guys, safety cannot be compromised. Take chances and the right tools. Turn off the power. That's the most important thing. And lockout tagout procedures. Turn off power. Lockout tagout procedures are very, very important. So don't take chances. Okay. Any question about the safety before we move into licensing and permitting and talk about Minnesota safety? So to summarize the safety, gentlemen, you lock, tag out any circuit when you work on the energized. Done. If you have to work on the energized, if you have to, because it's in a hospital or because you can't troubleshoot it, or your electricians can't troubleshoot it without being energized, you have to put the proper PPE on it. So that's basically PPE 0 through 4, category 0 through category 4. Licensing and permitting. Most of the communities, guys, in the U.S. have licensing and permitting. In the state of Minnesota, we have licensing and permitting, meaning in order to do electrical work in the state of Minnesota, you have to be licensed, bonded, and insured, and working for an electrical contractor who is licensed, bonded, and insured. That's how we do work in the state of Minnesota. You can't, so you yourself have to be licensed. The contractor have to be licensed as an electrical contractor, bonded, have a $25,000 bond, and insured, have a bunch of insurance for personnel and equipment in order to practice work in the state of Minnesota. That's what Hunt and Egan and C Electric and all this good stuff. Yes, sir.
Does that include personal things on private property, like if you yourself put up a Morton building and wanted to get it set up?
You're supposed to. Supposed to be inspected.
If you work on that, we actually have a slide about that one. If you work on your own home that you homestead, you can work on your own house that you are living in your homestead, not the one that you're renting, not the shop that your shop, just the house that you're living in, and you own. You can work on that one, but you still have to pull a permit and have inspection.
Sure.
So that's how we do in the state of Minnesota. But other than that, you need a license when you work in the state of Minnesota, as we do a master, and we have journeymen, and we have registered unlicensed electricians like you were. Those registered unlicensed electricians cannot work by themselves. They have to work supervised by either a journeyman or a master, 2-to-1 ratio. 2 journeymen, 2 apprentices, they call them, 2-1 journeyman or master. So that's how we do it in Minnesota. A lot of communities are the same, guys. You have to pull a permit before you start the work, and you have to do an inspection, at least 1 inspection, if not 2, in Minnesota, electrical work inspection. So that's That's, if you're a project manager, that's your job. You're gonna make sure you pull the permit, make sure you have your electrician ratio, adjournment to 2 apprentices at least 2 apprentices to at most 2 apprentices to adjournment. You can't have 3 apprentices to adjournment. You violate the law, believe it or not. So these are how, when you do get take off for me, when you do the estimation, that criteria is going to be in how you're going to do your crews. You can't go more than 2 apprentices to a journeyman. A lot of people union, they go 1-to-1 the ratio even, or 2-to-1, 2 journeymen to 1 apprentice on some jobs. So these are very, very important, guys. A lot of communities in Minnesota and elsewhere, they have to have a permit, to pull a permit. You do inspection, and the people who are working on it have to be licensed, bonded, and insured. So that's all through the Department of Labor and Industry. Homeowners, we just talked about this one. Homeowners can pull a permit. You have to pull a permit legally, and you have to inspect your work, but you can't do it yourself. And they're very clear, guys. They know that people like Chad might, moonlight and things like that. So they've made it very clear that you yourself have to do the work. They don't want you to go hire a journeyman, under the table, and see, I did it like a lot of people do. And they're very clear about that one is you yourself have to do the work. But you can pull a permit, get it inspected. You don't have to be a contractor, but you have to work on the things that you own and live in. You rent, you can't work on your rent. If you rent, you can't work on that. Okay, then moving on. So that's basically Minnesota construction. Moving away, guys, to the construction requirements. When you do a house or what's not, we have the plans. Or the prints or the drawings, or these are the ones that we have for a house or a commercial building. You guys are going to be generating this one with me later on. So that's how you translate all these into rules and regulations, into our rules and regulations. Okay, plans and specification. Plans, you guys are the ones who know. Here's the plans right around you. These will show all the layout, convey detailed. Moving away, so it convey what's a plan? Drawings, basically. Detail for construction and contain material list. I always say, guys, because it's too, you can't, it will take you basically, you have to write a book to describe where you're going to be putting a receptacle in the kitchen. So what we do, we have symbols and we throw them in a drawing, and we all know what these symbols mean. We basically create a new language. All these stuff that you guys do, it's a new language. So only people who read and understand this language can read it, right? If you give it to an average Joe, they have no clue what you're talking about. Different language. They don't know. They don't speak the language, right? So we create a new language. We put them in sheets, and we call them blueprints. That's our symbols. Specification. I told you guys you're going to have a specification. Is a big fix. I showed you yesterday that big fix specification. That's detailed information, description about the material that you're installing. There's very, very important thing, guys. This slide right here, specification take preference over the plans. So if your plans, if your specification says 500 amp panel, and your plans, where's my plans? And my plans say 600 amp panel. Then which one are you going to take? Which one somebody screwed up, basically. They didn't update the specification. That's what happened. Specification always right. Takes over the plans. Because typically specifications are controlled by engineers, guys. They don't allow you to mess with them. So, the blueprints done by designers and everybody else. So if you screwed up the plans, hopefully the specification will cover it. So specification covers, take a preference over the blueprints. Okay, so what are they? They're written instructions and information about the job. A lot of stuff you're going to see, guys. What type of material are allowed? For example, a lot of commercial building, if it's wood building, you can use raw mix to wire it. Do you think a good engineer would use raw mix to wire a commercial building? No. So what do? If you don't say that on the specification, CA Electric will come and grab a bunch of raw mix and basically pull them right through the commercial building. So they say the following is acceptable wiring methods, and they put AC cable, MC cable, EMT. These are the approved wiring, rigid if you want to, or equivalent. So they limit you with the number of wiring methods. Any question, guys, about the plans and specifications? So important when it comes to commercial industrial, especially. So that's your plans. On the plans and specification, we use symbols, guys. You know what the symbols are? We use a symbol like every time we need a receptacle, we put a symbol like this. And then we keynote the symbol. These are called keynotes, keynote number one. So we put keynote number one and we say, we want this one 50 inches above finished floor for whatever we needed. 50 inches above finished floor. Or instead of 50 inches, typically you just say, I don't know, what's 50 inches? Let's just say 5 feet above finished floor instead of 50 inches. 5 feet above finished floor. So that's how keynotes. You keynote all these, if you need to keynote. That they call them first the symbol, then the notations. The notation on the drawing, there can be a keynote like this or a general note. A general note, guys, would say right in here. You'll say a general note number one. All receptacles shall be GFCI. That's your general note. Keynote when you put a number right next to the symbol and indicate that this height of this receptacle is going to be 5 feet. So these are, so what are the extra information for the installer so they can do it right? Because if you don't do them 5 feet, they're going to put it on average a foot on center, you know, unless you tell them otherwise. All these symbols, guys, are coming from ANSI, American National Standard Institute. You guys have a list of these. I'm going to give it to you on CAD today, as a matter of fact. We'll be looking at it. So that's our specification. So because, like I said, it's a new language, we put them on blueprints, and you and I and the only electrical professionals can read them. Talked about that. National Electric Code and NFPA, guys, are the Bible. I will bring my collection of IDC code book, guys, here. Up to the 40s, I have full collection one day and show you. Did you guys see? I don't think you saw them last year. I didn't bring them. This document is going to be next, if you're a religious guy, next to the Bible or whatever your belief system is. Right next, electrical Bible. Going to make good money out of this document, so respect it. Every time they change it every 3 years, make sure you guys understand it fully. It's because it is the law. It's not just a book. It's the law, the electrical law. It's published every 3 years. You are the lucky ones. 2014 is, guys, the latest, fresh coming out of the print for you guys. 2014. 2017 is around the corner. So that's the next cycle. It's published by NFPA. It's called NFPA 70. Out of thousands of documents the NFPA publish. They're all free of charge, guys. If you go to the NFPA website, and you will be able to access every single NFPA document free of charge. That's what's nice about these, especially when you become a professional and you need something NFPA 101. I don't have that document. I want to go look at it. You can go there. You don't want to buy it because it's expensive, and you don't really need it a lot. You can go look at them free. Yes, sir.
When they come out with the new one, do they give you a list of what they changed, or you gotta read it to find out what they changed?
Good point. They don't. They highlight. They shade the changes, and they put lines and dots next to the ones that they deleted. Lines next to the new stuff, and shaded the the new stuff. So that's how they shaded the new stuff. But you cannot. It's complicated. So the way we do it, they have the International Association of Electrical Inspectors and a bunch of other guys take the changes, illustrate the changes, make pictures out of them, and present it to the people. And that's what we done for you guys when I did the plan at Michelle Cooley. We use some of these information and we present it. So you need somebody to explain it to you, put it this way. And those are the guys, they put every 3 years, if you ever look at their documents, every 3 years, they put a really good book about the changes, guys. Every time a new code book comes, they have a book with beautiful colored pictures about every single change. So, and that becomes almost industry standard. So if you want a code update, we teach them in 16 hours. We take this book with PowerPoint presentation, walk you through 16 hours of code change, and now you're ready to the new code. That's what most of the electricians do. In 16 hours, you bring it up to speed to the new code. In order to understand, guys, the IDC code book, I've been using it for a while, you must go to the definitions. And we're going to be talking about the ground. What's the difference between grounding conductor, grounded conductor, bonding conductor? All these terminologies, you have no clue what they are unless you go to the definitions. I always say, you can say anything you want. You have to define it. Where do you define it? You define it in the definitions. So that's the start point. There's 100 definitions. I don't know if you've done that. IBW and MA, we give them to the apprentices. We say 100 definitions you must know before you even understand any sequence book. I'll share them with you guys as we move through. You have to understand them. So it's just as easy as you go there and read them. 100 definitions. The latest and the greatest, obviously, is 2014, the most recent, adopted in the state of Minnesota. We adopted it in the state of Minnesota, guys. Statewide, we adopted. Other states, I would say most of the states adopt any sequence book, but you'll be surprised. There's some state that's still 2 or 3 cycles behind. So always check when you go work in different states. In Minnesota, we always adopt the newest one in July 1st of the year that's published. July 1st, always. But Wisconsin, I think they are in 2008 yet. I think they're moving to 2014. I don't know where Iowa is, but I can't
I'm
remember.
not sure, but why would they want the old one?
Well, some people don't want to change. It's too expensive to change. People. It's easier to sit for 6 years instead of 3 years. It's money typically. Inspection code. This is an inspection list. I talked a little bit about it, guys. That's called an inspection list for existing buildings, and a PA. So it talks about how do you remodel the electrical building and inspect them. You guys don't do so. If you are getting in an apartment building and you need to remodel the apartment building, it'll be a good idea to look at 73. It's most of the stuff is of course from an FBA 70 here anyway. An existing building. Building code. In Minnesota, guys, we have something called the code. Believe it or not, this national electric code is part of a big fat fluffy code in Minnesota called the building code. So here's my building code. This is my building code in Minnesota. And the national electric code, NEC, is this part. Can you guys see that? I want you to see this pie, construction pie. We as electrical engineers and electricians are only 10%. We're as much as we love each other and we think we own the whole universe, we're only 10% of that engineering and construction pie. So when you go in the field, act as you're 10%. Don't act as if you own the project. There is a lot of other disciplines, a lot of engineers, a lot of our designers. And your code that we love dearly is only 1% of the building code in Minnesota. What are the rest of them? Well, mechanical code, plumbing code, there's tons of other fire alarm code, all these building trade codes and high pressure and what's not. So all these make the building code. So in Minnesota, like I say, building code is very important. This article is very important, guys, because you are listening. Talk about you are listening. Can I go grab a coffee can and put a socket in it and make it a lighting fixture? A lot of people, by the way, there's pictures on the internet if you go there. A coffee can, a guy had a coffee can with a socket and he created his own fixture. With a socket, you can create any fixture and make it a can, like a light can, with a coffee can. Can you do that? Well, you can, but is it legal? No. Why it's not legal? The question you're going to ask you, why not? Listed and labeled. Show me the UL list and label for this coffee can. We're creative. America, we're free. You can do anything you want, right? Can I use the hose, the garden hose, the garden water hose as a wiring conduit? Can I? No. Why? Why? It's not listed or labeled. So this section is going to be very, very important for you. You're going to always ask, is it listed or labeled? Is it listed or labeled? Listed or labeled. Who lists and label? Not me. UL or other third parties. Those are the guys, they test them and list them and they say, yep, they're safe to be used for this application. Not check. Otherwise, a lot of creativity happening. Okay, moving away to the metric system. Like I said, the only thing I'm going to talk about, guys, the metric system is be aware that there are projects that's done on the metric system. Most of the projects, I would say, at least my experience, 90% of what you're going to see is here This is probably to make 10% of your work on a metric system, meters, instead of foot. So be aware of that. All the tables in the SQL book have metric as well as standard. If you do the calculation, load calculation based on metric, meters, square meters versus square feet, there will be differences between them, but that's acceptable. So any one of them will meet. So if you have a project in Brazil and you need to size a service for it, you can use a meter. I can't remember how many volt amperes per meter, which is equivalent to 3.5. If it's an office building, 3.5 per square foot. You do the equivalent for meter, how many meter, multiply by how many square meter, and you size the building. And that will meet the calculation. Either one of them will meet or compliance with any SQL book, the metric or the standard. OSHA guys require all the electrical equipment that you use. Electrical equipment have to be installed, have to be listed and labeled. It's the law. That's why the coffee can cannot be installed, not because it's not creative, but you have to just go to UL and get it listed and labeled. And guess what? Costs you an arm and leg to go through the testing and labeling too. So OSHA, which is Minnesota OSHA and federal OSHA, which is a law, the law of the land, force you to list the equipment, list them and label them. This is a big deal, guys. Listed equipment and they call it nationally recognized testing laboratory. A bunch of them, UL, ANSI is one of them. ANSI actually works with UL to get a couple of things listed. They are third party. If you ask me how is Chad, I'll tell you I'm the best person on earth. You have to have a third party verification. That's why they have UL, guys, is a third party verification. You make switch gears, right? Yep. My switch gear is the best switch gear on earth. Well, it's your switch gear. Of course it has to be the best switch gear. I need a third party verification. Nationally recognized testing laboratory. And not just any person that you can buy them. It has to be nationally recognized. They have a reputation like UL. Those are the guys that can guarantee you that the equipment guys are listed and labeled for the work that need to be done. So what do? They test them, they blow them up basically, test them and make sure they meet the safety standards. And then they list them, they put them in a list, and they have a label. That's what they do. So 200 amp panel, yep, they pump 200 amp into it, and it's supposed to sit forever. They set it for 4 hours. Did it blow up? No, it didn't. Check, listed, done. It can handle 200 amp. They put 250, blows up. Well, I want the listing for 200, not 250, right? So they test them based on what the manufacturers are listing them for. The manufacturers say 200, they put 200 in there. So that's how they label them and test them, and that's how you guarantee that the equipment are safe. So testing is for safety, very, very important, guys. Meet the safety standards, then you label them and test them. And the whole idea, guys, can you install an unsafe equipment safely? If that fixture is not safe by design, can you design it, like lay it out in your building and install it safely? You can't. You can't install an unsafe equipment safely. So that's why UL comes. The safety starts, guys, with the equipment that you install. Is your equipment manufactured safely? Yep, check. Now we're going to go in the field and install it, design it safely. Check. Then you're going to go in the field and design it safely. Check. Then we're going to go in the field and we're going to maintain it safely. Check. Now you have a safe system. So manufacture, design, construction, and maintenance. 4 legs for that stool in order to achieve safety, guys, in the electrical system. Very, very important. A bunch of them here. I'm not going to bother you guys with all of them. UL is one of them. The Canadian Standards Association is another one of them. This guy, ITS, is a third one. NEMA is a fourth one. There's so many of them, guys. You hear about NEMA contactors when you guys were with us here with the contactors I use in the second semester. NEMA contactors 0 through 9. All these are listed and labeled by NEMA. So these are third-party verification. Okay, so that's basically what I have for you guys. Any comments, any questions? Comments, questions? Yes, sir.
I just realized your name's in the book.
Is it?
An acknowledgement?
Oh, boy.
Yeah.
Thank you. Yeah, I reviewed a couple of them for him, yeah.
Pretty cool.
Yeah, thank you. Any comments, any questions? I do move fast. The information, guys, is a lot. You get excited, like I said, about it. If you read it, it's overwhelming sometimes when you read, but you're beginners. Remember, give yourself 10, 20 years and you'll be expert, but love it. I really do. Read it. Read as much.
Remember about the third time you
It will. It will. Believe me, I've been using it for 23 years now in the electrical field, and I've watched the code goes up, and you guys will be the same thing. You're the new generation watching it going up. By 2035, you guys will be the experts, or 2025, right? Okay, that's all what I have for you guys. I want to show you a couple of slides. Why don't we have 5 minutes? Let's take 5 minutes break, and then we'll reconvene. Thank you. Your semi-undivided attention. We talked about, guys, electrical circuits. This is just a couple of measurements of electrical circuits. When you have a switch like this, and you're measuring the voltage across a switch, you can get 120. So be aware of that one for safety. This is a typical lockout, tagout procedures for a commercial building. Look how you can have the lock and the tag will not open. So the only one who has the key for this piece of equipment is you. Anybody knows why? Because that's a safety feature. Lockout, tagout procedure. Very, very important for commercial. This is required, guard, for any machine, any type of machine, HVAC, any type of machine required to have a NEMA rated, some type of a disconnect with a tag. This type of disconnects are typically for lighting circuits. Can you guys see that little deal that you can lock it right here? When you're working in the electrical construction industry, guys, all the receptacle that you use for a construction site must be GFCI or GFCI protected. So they have this GFCI power strip right here where as you plug in and you're doing construction work, it's required by OSHA to have GFCI protection in all the receptacles that you use. So you see these all the time on the construction site. Permit. This is just an application. If you guys go to the Department of Labor, Minnesota, you can find a permit that you can pull. This is a typical application for permit that you can pull in order to do work. Look at that. Contractor information and signature, electrical permit, service inspection or revision. So give you some information, guys, what you're doing, motors and air conditioning, and the dollar value that assigned to inspecting these equipment. So from 100 to 200 amp, they give you $50 inspection. I think it's in Minnesota up to 100 amp is 35, if I remember right. The permit is $35 for dwelling. So this is a typical permit. What's in it for you guys? Look at it. This is what you're going to be filling when you become an electrical project manager. That's your job, to fill and file. On Minnesota, guys, you can file all these right now online. They call it e-track. You can file all these permits online. It's great way of doing business. This is just a 3D wiring. You guys can do that one in Revit. When you wire your stuff, you can get in Revit picture. Symbols and notification for receptacle. This is what I want to emphasize. This is just arrangement of the NEC code books. I should turn that. That's much better. Okay, look, this is how the NEC code book is laid out. We have 9 chapters. Probably 90% of the time, you guys are going to be right in here, in these chapters. This is called, applies generally to all electrical installation, general, wiring and protection. All the wiring methods, guys, are going to be right in here. Wiring and protection in terms, wiring methods are going to be right in here. We have the equipment, motors and HVAC equipment are going to be right in here. So these are the chapters I will be going through the whole year with you. Chapter 1 through chapter 4 of NEC code book. These guys are special supplement or modified chapter 1. You can see they are supplementing chapter 1 to chapter 4. Special occupancy like gas stations, aircraft hangars, hospitals, and what's not. Special equipment and special conditions. Special conditions right here, 725, 760, fire alarm system, security system, and so forth. So these are all the application, guys, special occupancy, special equipment, or special conditions. Chapter 8 is strictly to the communication, applies to rules in chapter 1 through 7, applies only if reference in chapter 8. And chapter 9, guys, tons of tables. And there's some informative annexes A through J. So that's the layout of the NEC code book that you have in front of you. We're going to be digging in and picking certain information. So important to understand what you have, guys, right in front of you. Does that make sense? 90% of your work is going to be in chapter 1 through chapter 4. 10% probably right in here. 10% of the stuff that we do is right in these areas. Any comments, guys? Any questions about the NEC code book? Again, we're going to be digging into them as we go through to UL. We talked about the UL listing. This is how you show the UL listing for the equipment. That's what you're looking for. You like my smart board? Yeah. A couple of UL. White book. Anybody have seen the white book or heard about the white book? The white book, if Chad grabbed from his hometown in the Middle East, grabbed the lighting fixture and brought it to install it in Minnesota, and you are the project manager and said, okay, no problem. Is this listed? Yep. Where is it listed? UL. And do you take my word for it? What's your listing number? I give you a number. Create a number. Where would you verify if this number is right or wrong? The white book. So the white book, guys, you go there, create book for project managers. You verify that what I'm telling you is the right thing. I can't tell you anything you want to hear, right? You can verify. That's how you can say, the information is really what people are telling you. Because you have counterfeit equipment. Counterfeit equipment is a lot. You want to verify if it's listed. Yep, you go to the list. It's not listed, then it's not product. And there's a lot of UL guys that can help you with it. A lot of listing and other equipments. This is just back into the NDC code book, guys. A few things. Description of the NDC code book. 90 is the introduction. Article 90 will tell you where does the NEC code book apply and where it doesn't. It applies for all buildings. Does it apply for airplanes, ships, cars? No. Does it apply for mining? No. Electrical utilities, those transmission, distribution, generation of power? No. So that's where does it say that in that article? So for you guys, most of what we do is building. It applies for every single thing that you're going to touch, except what you touched in the past, which is electrical utilities. They have their own code, basically. Chapter 1, guys, talk about definitions right here. Article number 100 is very important. It defines, when I came to the US in 98, I grabbed any secret book, read it from A through Z. Being an engineer, went tested for my master electrician, scored 55. Never seen the book before. So, read the book. I'm not kidding you, from A to Z. So I thought, I need more explanation than just reading the book. So anyway, next time I got 83 and I got my master in 03. But my point is the single most important thing that I did and I was told to do when I read the book the first time I've seen that document is definitions. You can read things, but you don't understand it. You have to go through the definitions to understand any secret book. Grounded conductor, equipment grounded conductor, corner grounded delta. All these things, guys, are directly in the definitions. Requirement for electrical installation. That will tell you that you need a 3 feet right in front of this piece of equipment. 3 feet clearances, the width of the equipment for clearances, very, very important. Apply to the installation. Wiring protection. Wiring and protection, it talks here, a lot of stuff, guys, talks about overcome protection devices here, branch circuit, and a bunch of feeders and what's not. 230 service, feeders, branch circuits, overcome protection devices. Why can't I use my water hose, garden water hose, as a conduit system? Because it's not listed in chapter 3. If I want to list it, no problem. Go take it to the UL, lets them list it, and put it in any secret book. It becomes the hose, the water hose, garden water hose can become now a conduit system. Why can't I use barbed wire as a current carrying conductor? It does. Have you ever used it? It would carry current if you wanted to. It's not listed as a conductor. Where do they list it? In chapter 3. That's your answer would be as a project manager. If you have a smart aleck like Chad, a coffee can light, and all creative people, your answer is going to be, is it UL listed and is it in chapter 3? then we can use it. Equipment, all these equipment, guys, panels. Why can't I custom design your bag, right? You can make a panel, electrical panel. Take a couple circuit breakers, put it in the wall, right? It's not UL listed. It's not. If it's UL listed, it's the panels are there, but it's not UL listed. All the panels and transformers and generators and motors are in Chapter 3, guys. Equipments. Special Chapter 5 talk about special occupancies, which is basically a lot of gas stations and printing area and hazardous location and what's not are there. Aircraft hangars, bunch of them. Special equipment in Chapter 6. Chapter 6, and then special conditions talk about special conditions. Typically, fire alarm security, phone data. No, fire alarm security is typically there. We'll talk about these one guys in the spring when we talk about emergency system, legally required standby system, and bunch of other systems that you required in the building in Chapter 7. Chapter 8, telecommunication system and internet. If you're doing internet and telecommunication system for a building, or fiber optic cable installation for internet and telecommunication, and power broadband and all this good stuff in chapter 8. And Chapter 9, guys, tons and tons and tons of tables. So please look at this carefully as you read the NEC code book, how they're defined, and you will spend the rest of your life, guys, understanding this document, basically. That's it, and your career. There's also annexes. I want to highlight a couple of annexes that must know as electrical. You guys have all these. Here's what provide comprehensive product safety standards. You are listed. This Annex A safety standard is a good comprehensive list, like the product safety standards is a good one to know. Conductor with this one. After 25 years in the field, or 20 years, you'll start using this guy. Annex B, engineering supervision. You have 24 ducts underground. All of them are carrying 500 kcm, 4 conductors, 500 kcm in each one of these ducts. How much current each one of these ducts can carry? Nothing in any secret book can tell you that right now. Engineering supervision, that's what you do at Mishad College. You know what I mean? So that annex is really interesting when you work for an engineering firm. When you take it to the next level, guys, that's way the next level. After you know how to use the code. The other one showing the maximum number of conductors. C is very important. Also, it tells you how many conductors you can fit in a conduit if they're all the same. Example for load calculation. These are really cool. It gives you example how you do load calc. This is what makes you expert when they talk about construction. Type of building construction, type 1 or type 5. Type 5 is wood. Type 1 is typically concrete. Do you think when we have a wood building, we use the same wiring methods as if we have a concrete building? No. You can't use raw mix in a concrete or steel building unless you put the raw mix in an EMT conduit like these. Now, who in his right mind will put the raw mix in an EMT conduit to use it here in Dunway in this room? So anyway, so there's a lot. The construction type, very important, guys. If you work for engineering firms, very important. Yes, sir.
I was curious what Romex is, because you keep referencing.
Romex is this here.
What is it?
It's a cable wiring method. Oh, you guys haven't seen it. I should. I'm sorry. I'm using it. This is what they use in dwelling. That's basically the dwelling. The 99.9% of the time you use in dwelling. It's a cable. It's called non-metallic sheath cable. The NEC code call it. It's called Romex, is the manufacturer of that.
But you wouldn't use that in type 5.
You use it in type 5, but you wouldn't use it in type 1. Depending on like here, inside this block, you can't use it. It's not approved. It's approved to typically wood. So wood construction for the most part. So then if you have a type like this, then you're going to use an MC cable, an AC cable, and so we'll talk about the wiring methods as it goes. But these are this is basically the cheapest wiring methods that you can, other than barbed wire, which is, I think barbed wire is more expensive than that one probably. This is the cheapest wiring method they can use. That's it. That's what we use in dwelling all the time. Okay, American with Disability Act, they added it in 2014 just for you guys. So it will tell you how high you can put your receptacles and switches and still meet American with this. You guys familiar with American with Disability Act? This is for the people who are disabled, so they can have free access to public places like you and I. Easy access. So they have rules, really cool rules that applies to them. So that's probably, this is the most important ones there for you guys at this time. Reliability of critical operation for a system, these are a little bit more the next level taking it. So these are the annexes. We talked about, the way the secret book is done, and then I'm almost done here. When you talk about the secret book, here's how they do them. Look at, they start always with a chapter, guys. So you have your chapter, then you have the article right underneath it. They have Roman numerals. The parts are in Roman numerals. Then the sections. Can you guys see how here's a chapter, here's an article, here's a Roman numerals is the part, and here's a section. The section typically put dot something. That will be the section. We have paragraphs too under these. So they put a one. Look at that. They put a and one after that. It becomes a whole paragraph at list. We have list two. Here's list 1, 2, 3 items under B. And we have exceptions. Then in secret book has love exceptions. They will tell you the following rules. You cannot, all receptacles in a basement must be GFCI. And right underneath they say exception. A single receptacle dedicated for fire alarm or burglary alarm system is an exception. So if you have one receptacle in your basement, unfinished basement, you plug in a fire alarm system or a burglary alarm system in it, doesn't have to be GFCI. And so guess what the contractors do so they can screw you guys up when you're designers? They go to the exception. You know, the rules, we all know, a lot of people know the rules, but they go tiny little exception and they use it. It saves money. Exception saves you money. And then there's FYI info. This is FYI for your information. FYI for you, you guys familiar with the term FYI for your information? This is information, just to inform you. It's not enforceable. It's not part of the code. And then there's also annexes, informative annexes, also FYI, unless it's referenced, are not enforceable. You're going to hear when you talk about any secret, guys, they always tell you not enforceable. Anybody knows why it's not enforceable? This is the law. If you put it in this book, it becomes a law. So if it's a law, it has to be enforceable. So they have to tell you what's enforceable, what's not. So if it says informational note, non-enforceable, then you can't force the people to do it in the field. This is just a best practice and what's not. Any comments, guys, any questions about how the any secret book articles are listed and labeled? From chapter to article to part to section to paragraph to list to information note and information annexes. So this will give you guys hopefully an overview of the system. This is just a few things about the trade size versus we're switching a little bit here from the any secret book, guys. This is, I like that one because it's when you say trade size versus actual size, very important, guys. So for example, here's an EMT conduit. All these are half an inch EMT and non-metallic tubing. And look at the actual diameter, interior diameter. They're different. So all these are half an inch in the trade. They will tell you half an inch rigid, EMT, PVC. All these are different types of conduits that are right here that we're going to be using, approved conduits that you're going to use. You know, this is 3/4 of an inch, but you have a 3/4 of an inch rigid, EMT, PVC, non-metallic. It's close to 60 wiring methods in the DC protocol. And these 60, you guys, your job is to be kind of pick the right wiring, the best wiring for the right application. But look at the diameter are different, so but they refer to them by the trade name. So trade size is not the actual size. Just be aware of that one. Okay, here's a couple of this is metric designator versus trade size. So if you have 3/4, here's 3 inch is equivalent to 78 millimeters, I believe. These are different trade sizes. Trade actual size for the trade size knockout tool is different. So just be aware when they say half an inch EMT, If you go measure the interior diameter of it, you're going to find it different than half an inch. They're trade sizes. And then this is converting, guys, from metric to, you guys have seen that one before, converting from metric into, I'm sorry, these are the multipliers. I would like you guys to know at least the K and the M for us, which is million and 1,000. These are very, very important, guys, when you say 1.2 megawatt generator. And you need to do calculation for it. You need 1.2 is, you need to know that's 1,200,000. Is that 1,200,000? So that's your multiplier. Everybody's familiar with these multipliers? Multipliers for the stuff that we do. This is just a couple of conversion inches to centimeter. Do you guys remember that little tiny converter that I showed you yesterday on my favorite? Grab that one. You don't have to worry about these anymore. You can convert from any unit to any unit. But if you're wondering what would an inch equal in centimeter, 2.54. What would a meter equal in centimeter is 100, or vice versa. In feet, a yard is almost a yard is a meter. If that's how I always use it. Comments about these multipliers? Straightforward, nothing to it. Inches to meter conversion. You guys have a calculator, and that's basically it. You have a calculator that I showed you. Download that one, and you can convert from one metric to another. You don't need to go do the multiplication. What's not? That's all I have. Any comments? Any questions, gentlemen? Please read this chapter. It's really good info to know. As I said, if you're not overwhelmed, then you are not with us. It's a lot of information, guys. But as you go, give yourself 5 years in the field, and it'll start sinking in. Cool? All right, so what we're going to do, I'll give you guys, I want to do some CAD today. So I'm going to give you what time? It's 9:30 right now. When are you going to check on your laptop?
I think around 10 maybe.
Around 10? Okay.